Hello, this is Prof. Aram, and in this video, we're going to look at the impact of increasing the compounding frequency. So let's get to this. So in this section, we will look at the effect of increasing the compounding frequency from annual to semi-annual, quarterly, monthly, daily, etc. and see how this change impacts our cash flows, present values, and future values. Let's say we have two situations. One, you're going to earn 8% annually, and the other one you receive or earn 8% semi-annually. If you look at the semi-annual one, that means that you earn 4% every 6 months. So in the first 6 months, you earn 4%, and in the second 6 months, you earn the other 4%. So is the 4% earned every 6 months the same as 8% earned annually? It's actually very easy to show. So the future value, in case of the annual one, the future value of $1 would be 1 times 1.08, which would be 1.08. And in case of a semi-annual one, future value would be $1 times 1.04 raised to the power of 2, because now your rate per period is 4 and you have 2 semi-annual periods. So in this case, the future value of the dollar would be 1.0816. This 0.0016 dollar that you receive extra from the semi-annual investment shows you that your account earned 4 cents in the first 6 months, and then you earned 4% of that in the period after. So this is the effect of compound interest that we've seen before. But now you notice that if you increase the compounding frequency, the compound interest increases as well. The more frequent you compound, the higher the future value. That leads us to the concept of effective annual rate. This is the actual rate paid or received after accounting for compounding frequency that occurs during the year. If you want to compare two alternative investments, you can't really compare their APRs or the nominal rate or the quoted rate. You need to compute their effective annual rate, the EAR, and compare those investments using the EAR. So always use the effective rate for comparison. It's very, very important. We never use the APR to compare investment opportunities. The right rate to use is the effective annual rate. Another rate is the annual percentage rate, or APR. This is the nominal or quoted rate. Whenever you look at, for example, a credit card offer, by law, they have to show the APR with a larger font in the offer. So every loan document that you have should state the quoted or the nominal rate of return. By definition, the APR is also your periodic rate times the number of periods. So if you have monthly rate, so the APR would be your monthly times 12. If we have quarterly rate, your APR would be quarterly times 4, and so on and so forth. So because of that, to get the periodic rate, you need to divide your APR by the number of periods per year. So if you want to calculate the daily rate, that would be your APR over 365. We never divide the effective rate by the number of periods per year, right? It will not give you the periodic rate. We always divide the quoted or the nominal rate by the number of periods. So for example, if your monthly rate is 0.5%, your APR would be 0.5% times 12, which is 6%. Or if your if your semi-annual rate is 0.5%, then your APR is going to be 0.5% times 2 semi-annual periods per year, which is going to be 1%. Of course, if your APR is 12% and you're doing monthly compounding, your monthly rate would be 1%. It's very important to remember that you always need to ensure that the interest rate and time period match. So in any problem that you see, like this is the original future value formula that we looked at, always time period should matches the rate per period. When we were looking at the annual compounding, we didn't have to change anything. T would be the number of years and R would be the annual rate. But if you increase the compounding frequency, you have to change your R. Also, you have to change your number of periods. Your R would be the periodic rate, which is the APR over M, which is the number of periods. And your T would be years multiplied by M, which is the number of periods. So they always should match the periodic rate and the number of periods. So how do we compute this? Suppose you can earn 1% monthly on the dollar invested today. What is the APR? Of course, is going to be monthly rate times 12%. The future value would be $1 times 1.01 raised to the power of 12 months. So this is monthly rate raised to the power of 12 months. This is your future value, $1, 12 cents and 68. So this is your future value, $1.1268. And the rate of return or the effective rate on this investment would be your ending value minus beginning value divided by beginning value, or just 1.1268 over 1 minus 1 should be 12.68. So your APR is 12%, but your effective rate, considering the compounding, monthly compounding, is going to be 12.68. So this extra return that you earn is due to compounding, due to increased compounding frequency. You can do the same thing here, 3% per quarter. So your APR is still 12%, but now you multiply $1 by 1.3. That's quarterly rate, and 4 number of quarters. That's your future value, and you get 12.55. So of course, this 12.55 for quarterly rate is less than the monthly, because for monthly it compounds more frequently than quarterly. So that's why the monthly effective rate is higher than the quarterly rate. This is how we calculate the effective rate. 1 plus the APR over the number of periods raised to the power of number of periods minus 1. But I'm going to show you how to do it using the financial calculator. Let's just look at another example. You're looking at two saving accounts. One of them pays 125. This is your APR or nominal rate with daily compounding. The other one pays 5.3% with semi-annual compounding. This is the formula. 1 plus the APR over the number of periods per year, 365, raised to the number of periods per year minus 1. Let's see. Of course, let's just finish this. If we want to decide which of these are better, we can compare them by looking at the nominal rates, the APRs. That's not going to give you the right answer. The only way you can make the right decision is when you compare their effective rates. So of course, the one with lower APR, but because it's more frequently compounded daily compounding, has a higher effective rate compared to the one with a higher APR but less frequent compounding. Let's look at this in BA2 Plus. So in this one is actually fairly easy. There is a function for that, interest conversion. So I'm going to do second 2 and go to the interest conversion. APR is 525. Enter. Down arrow again. CY is the number of compounding per year. So we do daily, so 365. Enter. And then compute, 539. I'm going to do the same thing for the second choice, 5.3. But this one, I'm going to compound it only 2 times per year because it's semi-annual. And we get 537. Excel is also very simple. So let's look at this. To calculate the effective rate, you just use the effect function. Your nominal rate is 525, and then number of periods per year is 365, and you get the same answer here. And for this one, I have nominal rate is 5.3, and then for this, because it's semi-annual, I just use 2. And then you can just do the opposite as well. So if you require an effective rate of 12%, you can calculate the APR. So you use nominal rate as a function, and then solve for, this one is monthly. So 12, and then this gives you the APR for that investment. Of course, you can also do it in here. So if the required effective rate is 12% and you're doing it monthly, your nominal rate is 1139. So the key here is that effective annual rate is greater than or equal to annual percentage rate. I said greater than equal because if your frequency of compounding is just 1, meaning that if you annually compound your investment, then the effective rate would be exactly the same as the APR. But if you increase the frequency of compounding, then always effective rate would be higher than the APR. I hope you find this video useful, and thanks for watching.